Hey folks, hi folks, welcome to my channel. My name is Aakash, and in this particular video, we will be going to dive into the DeFi series continuation. Yesterday, like some of the urgent work I got some work, so I record some video. Okay, I recorded some video, so it was certain little bit kind of a sort of a stuff. Okay, so you got the clarity. I didn't got any kind of a reach there, so I'm thinking that creating whole content itself it will be work fine for everybody. All right, till then we'll get started with the video basically. So like I thought that uh, like this thing is not going to help you out. Okay, so I'm making a full kind of a content itself that will help you actually. All right, so let's dive into the open board and let's get fair understanding what we'll be going to discuss in this particular video we will be going to talk about. All right. So we discussed about what is an epoch, right? What is an epoch? We discussed, right? So what is an epoch basically, folks? Okay. Imagine you have a big pile of a paper, right? So we have this presentation, I guess. I don't saved, I guess. Okay. So what is an epoch? What is epoch? I'm just making you understand what is an approach in general sense and making you to understand how you can explain it in very general sense, folks. Don't think at like you have to buy heart the certain things they will be accepting that. No. You have to just tell that this is a general sense. Imagine you have a big pile of papers, right? You have a big pile of papers, okay? Like you can't read all that at once, right? If there are list of pile of papers, you cannot read at once. Raw means nothing but read at once. You cannot read all at once, right? So what you do, you will take the one sheet of a paper, like there are 5 to 6 pages. You can complete this kind of a stuffs, right? So like let's say each time you finish reading a one page, so that is considered as one batch, right? Finish reading the one batch, that is like completing the one approach. Okay, consider you have a paper. All right, consider you have a paper, list of paper, 5 pages are there. Okay, 5 pages of this particular newspaper. Let's say you complete one batch of that page, right? So that is nothing but a one approach. Okay, I hope you understood. This is the particular sense I am talking about it. So in the previous video, I didn't got any kind of a comments like I didn't understood this sort of stuffs. You are watching the video, you are not liking, and some of the guys are watching the video but not giving their emotions, right? So understand one thing, folks. Like I'm making the content for you, folks. Okay, so that you understand I should also grow. You should also support me so that I make a content like that. Okay, all right. So I hope this is clear now. Okay, so this is an approach basically, folks. Let's suppose you have a piles of a paper. If you complete, you cannot read all at once, right? So what you do? Let's say you completed the one page. Okay, you completed the one batch, that is like completing one approach. Okay, this is nothing but we call it as an approach. So this was about the general sense I was talked about. Now we'll just dive into the data science terminology so that you will understand. In data science, approach is when your entire data set, consider this is an entire data set. Okay, this is an entire data set, DS. I will be going to tell as DS. This is an entire data set through a computer program. Through the program you write, okay, through the program which you write, through the program which you write, Okay, it's like a neural network for both. Okay, it's like a neural network for both forward and backward. Both forward and backward. Okay. So if you wanted to, if you want a in-depth video about it, just let me know in comment section video, folks. So forward and backward, you will be able to understand what is a forward and backward. If you wanted to know about it, just comment down below. So this helps the computer learns. This computers learns from the data. Okay, data set nothing but it consists of the data, right? So it is too big to handle at once. So what we will be going to do, we will break this data set into the batches, right? This data will be divided into the batches, into the smaller parts, so that the computer can process this particular data. This, let's suppose there is 100 data set, right? So what I do, 25, 25, 25, 25, 4 times I will be going to divide into the 4 batches so that it can process this data. So one particular processing that particular data is nothing but as a one approach. Understood? So using just one approach is not enough, that because you might not learn to teach it might not teach the computer well. Okay, it could underfit, overfit. What does that mean? Like overfit basically means it there will be certain scenario that, like, your data will might perform for your training data, but if the new data comes, then it might not perform well. All right, so this is a particular what is all about the approach part. Now next thing we'll be going to discuss about is, like, what is a batch size now. Okay, I'm making very simple, folks. So if you go, just follow the, like, I'm just making sure of this series is like very basic, very mutual understanding. If you have not gone through the detailed video, so at least if you see this particular video, you will understand what is this all about. Okay, after that you can go one by one, watch the github source of the, like, ineuron. Like, I have given, in that repo they have given already all the things, documents in day wise. Okay, so you can go through that. So this particular series is all about to make it very simple, very basic, so that you can understand it. So next is, what is batch size? So let me know in a comment down below, folks, like how you are liking this series and all stuffs. Okay, so I will get to know like what kind of a content you want. Short form kind of a content that you like, or like long form of a content you are liking a lot, so that I will get to know about it, sort of process. Okay, I'm creating a lot of effort to bring you this particular kind of a questions and making very most simpler wise. Okay, so what is a batch size? Think of batch size as a number of a cookies. Okay, number of a cookies. Okay, let's say you have a 12 cookies. Okay, in a tray. In a tray, you have a 12 cookies. Imagine it is a 12 cookies you bake to the oven basically. This is an oven. Consider I'm a, I'm wrong. Like, I'm bad at the drawing, folks. Just understand the analogy. Okay, you are feeding into the oven. So in one batch, that is your batch size, right? Okay, 12 cookies you are considering and putting into the oven, right? In one batch, that is nothing but a one batch size. Okay, so if I wanted to talk about the data science, batch size is a number of pieces of data like rows in a data set. Okay, okay, batch size. So this will be a columns, this will be a rows, right? Right. So what you understand from this? Okay, so what we do is batch size is number of pieces of data like rows in the data set, so that you process all at process the data at once. So if your batch size is 32, it means that you are, like, you are looking at and learning from 32 pieces of data at a time. Okay, so one particular data, second, third, fourth, fifth, like 30 pieces of data you want it to run at all at once, learning from 32 pieces of data at a time. So larger the batch size, that makes the learning faster. Okay, smaller the batch size, that takes longer to train. Understood. So when you have a larger kind of a data, then it is very easy, folks. Okay. So this is a particular thing about the process. Okay, larger the batch size can make faster. That might must more need more memory, right? So smaller the batch size, training size will be the more. Okay, training the data will be the more. Okay, so let's say smaller the batch size may longer to train, but can be more precise in learning from each pieces of data. It's like deciding how many cookies to bake in each batch to get the best results without wasting the resources. Right. So this is a particular thing. So now we will trying to understand what is a dropout in neural network. Another thing they might ask is what is a dropout? Okay, what is a dropout? What is dropout? Okay, so let's say, imagine you are studying for a test. Okay, imagine you are studying for a test. Instead of studying every single page of your notes, you decide to skip some pages randomly, right? You decided to skip some of the chapters or some of the things for the test, right? This is like a dropout in neural network. Let's say, imagine imagine you have a midterm exam or final exam. You thought that you are pakka that in model 1, model 2, model 3 you will be going to, like, I will be rapat. I will be doing this particular thing. I will be having any questions that will be asking from three modules. I am perfect that. I am damn sure that I will be going to do it. So what you will do, you will perfectly learn these three modules, okay? And you go for the exam and you will write it in the exam, okay? But when comes it's your choice, right? I don't wanted to learn module 4 and module 5. Why? Because I will be forgetting the module 1, three modules, so that it will be very hard to pass that particular exam, right? This is what the dropout is all about. You decided that I don't wanted to learn two modules so that that will hamper my performance. All right, that is not a thing. Okay, you skip it some of the modules which is not required for you at the moment. That is nothing but dropout in the neural network. Okay, so in a neural network, dropout means randomly switching off some of the neurons, okay, like a pages of your notes during the training. This helps prevent the network from over relying too much on any one neuron, okay. Like let's take a different analogy, right? You told, let's say your friends are in the same room, okay? You tell to your friend that you learn this two modules. I will learn that two modules, and I will learn another two modules, okay? Okay. So what happens in this? In a neural network, dropout means randomly switching off some of the neurons. Let's say there will be one of the guy who will learn all the modules. He will say that I have learned only two modules. So what he is about now? He is not depending on other person. It is considering as other neuron. Okay. So it will make more flexible and better at generalizing. Okay. So what it learns. Okay. Just skipping some of the pages, like studying can help you to understand material better. Overall dropout in neural network. Okay. So now let's understand. You understood. I hope you got the clarity. I'm just giving simple example, folks. If you want correct clarification, correct definition about it, just let me know. I will record another video for that. Okay. So let me know about it. How this kind of a teaching you like a lot. Like how is it? Okay. So let me know about it. So now number 4 question, list down the Hyperparameter tuning in deep learning. List hyperparameter tuning in deep learning. Okay, hyperparameter tuning in deep learning. Okay, so I will be going to write it like this. Okay, hyperparameter in deep learning. So let's get started. Let's get understand from that. Okay. Like think of hyperparameter as settings to your phone. Okay. Hyperparameters are like settings to your phone. Like I'm just making very simple folks so that you can relate with general terminologies like settings to your phone. Okay, settings to your phone. Like just like an adjusting the brightness, volume increase, get the best experience in the deep learning. So to get the best experience, right? In the deep learning, hyperparameters are settings that you adjust to best performance for your neural network. Okay, understood what is it hyperparameter tuning is all about? Hyperparameter tuning is what? Hyperparameter tuning is what? Are the settings. Settings for what? Just stop the video and take it. Tell me this, folks. Okay. Hyperparameter is tuning for the settings for what? To adjust the best performance of a neural network. Right? To adjust the best performance of the neural network. Adjust the performance of a neural network. Adjust the performance of the neural network. Right? Understood, right? So what are the common hyperparameters that you will use? One is a learning rate. Okay, one is a learning rate. Another one is a batch size, BS, batch size. Okay, learning rate at what it should learn particular part, and number of epochs, right? Number of epochs. Then activation function. Understood? I hope you got the clarity now, right? Act, learning rate, batch size, number of epochs, and the activation function, then number of layers and neurons. So now I will explain you what a learning rate is about. Learning rate is like how fast you learn the new things. Okay, higher the learning rate can make the learning faster, but too high can make it hard to learn properly. Okay, in batch size, as I told you earlier, it's like how many pieces of information you can handle at once. Okay, so a batch size can speed up the learning, but too large can use much memory. Okay, then third is number of epochs. In how many times you go through an entire data set. More approach can lead to better learning, but too many can cause overfitting. I already told you overfitting. What do you mean by overfitting? The data which is algorithm which you train will work only on the training data well, but it will outperform on the new data, that is test data. Okay, I hope this got you clarity now. All right. So let's take another page and let's dive into understanding about uh, like what's activation function and error function. What do you understand by an activation function and error function? Okay, so let's get dive into the activation function now. So what's before going to the like very technical details, folks, we will just this objective of a series is making very straightforward and very simple understanding so that you understand this deep learning very fun way and very understanding way. Okay, so that you can relate with the real world. What is an activation function? First of all, imagine you have a light. Okay, you have a bulb or a light. You can switch either switch on or switch off, right? In a similar way, switch on or off, right? You can switch on or off. Okay. So in a similar way, a activation function in a neural network decides whether a neural should be active or not based on the input it receives. Okay, are you understanding? So activation function add a non-linearity to the network. Okay, so allowing it to learn complex pattern and relationship in the data. Are you understanding? So when you imagine you have a bulb, so you have a bulb in your home. So whatever the input goes, let's suppose if I switched on, it will go to the bulb, it will get to send the electrical signals to the bulb that this is the input is coming, I want to switch on this particular bulb, right? The same way in the neural network, the activation functions adds a non-linearity relationship so that it will learn the complex patterns and relationship from the data. All right. So now for the what are the examples of activation function? So you have might use if you have might have seen, right, ReLU kind of activation function, sigmoid functions, right? So these are the examples for the activation functions basically. Okay. So sigmoid function which say, squashes between the zeros and one, right? So which value is greater than zero? They are like sets of negative values to zero. All right. So we will get dive into it. Okay. Like what's if you have seen the logistic regression part, these are the things is linked with that. Okay. So we'll get dive into it later parts. We'll just complete this 30-day series of the videos in simple terms so that you will understand how much important is all about. Okay. So now second thing we have to learn about is error function or loss function you can call. Sometimes suppose you are playing a dots, okay, and wanted to hit a bull's eye, a distance between where your dart lands and the bull's eye is like an error in your aim, right? So in a neural network, the error function measures how far your network and hitting the bull's eye or missing. The goal is to minimize the error basically. Uh, let's suppose you have a stone, right? You have a this stone you have. You wanted to throw the bullseye. This is a bull. You wanted to throw his eyes. Let's suppose something here it got hit, right? That is a distance between them. It's an error basically. So different type of problems like classification or regression have a different error functions. So for example, mean square error is often used for regression task, while categorical cross entropy is used for classification task, right? Categorical cross entropy. So in simple terms, activation function decide when new neuron should fire in new neural network, adding a complexity to its learning basically. I hope this you got the clarity. Okay, so now we'll just get dive into another question, that is why do we need non-linear activation function? Why do we need non-linear? Why do we need? Why do we need? Why do we need non-linear activation function? Activation function. Okay. So imagine you have a toy car that can only move forward or backward. Move forward or backward. This is your toy that can move forward or a backward. Okay, move forward or a backward. Okay, move forward or a backward in a straight line. If you wanted to turn left or right, you need to add something, right? That can make it turn it to steering wheel. So uh, let's say imagine your car, you are driving, right? So if you put the gear forward, it can go like you have to hit the clutch, you have to push the gear and put in the so that it can move. If you want to push the backward, you have to put into the reverse gear so that it will go back, right? So this is the particular thing. So if you wanted to turn left, you have to you have to put that wheel, so steering wheel, to move it to the left or right, right? Understood? This is like a steering wheel. So in a neural network, nonlinear activation function acts like a steering wheel. Okay, they allows the network to learn more complex pattern and relationship in the data. Okay, without them, the network would only be able to simple straight line relationship in a toy car moving with a straight line. Okay, let's suppose you put it into the first gear itself, right? First gear, it will go into the straight way. It will go in a straight direction itself. If you apply something only, it will can stop, right? Otherwise, like putting a brake, putting a steering wheel, where to go. This is like a non-linear function which is adding to relationship to understand the complex data and relationship in the data basically. I hope this got you clarity. So non-linear activation functions are the crucial because they enable the neural network to handle and understand more complicated information, the more powerful in an effective for the desk, like tasks like recognizing images, understanding the language, making the predictions. You have got the clarity, right? Where how I build the like Java is kind of a system for basic system. Like I use neural network, I use NLP tasks, right? So it understand my emotions so that it can recognize it and it can speak up. The machine can speak up whatever I'm delegating the task for the Javas. Okay, it is a something like that you can consider of. Okay, why do we need a non-linear activation function? You got the clarity that part as well. And like why do you what do you under by vanishing gradient problem? What do you okay, what do you under by vanishing gradient problem, and how can you vanishing gradient problem, how can you solve that particular vanishing gradient problem? How can you solve that particular problem? Okay, vanishing gradient problem, how can you solve that? Okay, so this is a particular question they are asking about. So imagine you wanted to reach a climb and you have to reach the hill of the mountain. Okay, how to reach this? Okay, so like what you will do, problem when happens is gradients, right? Which guides learning because become very small as they move backwards, right? Let's suppose you reach here, you get slided down and you can came it here, right? You came it backward through many layers of the new, through many layers, right? So gradient tells you which direction to uphill, so you know that where to go. But what if hill is really long, right? And the gradient becomes so tiny they that you cannot tell which way is way up. This is way up or this is way up. This makes it hard for the things, right? So that's like the vanishing the gradient problem in neural networks is all about. So okay, in deep learning, vanishing gradient problem happens when the gradients becomes very small as they move backwards. Okay, so they takes the small steps. They take small steps. So as they move, they slightly moved backwards, right? So he'll disappearing or like to solve this particular problem, we can use several activation function here basically, folks. So we for to solve this particular problem, we can use this activation function. Using the activation function like ReLU, residual linear unit basically. Okay, so this will because they squash the gradients and as much as allowing them to follow the better through the network. Then second, you can use the initializing techniques. Like you can initialize the values of weight so that it can prevent the gradients from vanishing too quickly. So you can use the batch normalization. This technique will stabilize and normalize the inputs to each layer, right? Fourth is skipping the connection. This connections allows the information to skip the layers, helping the gradients to uh, to go to reach that particular goal, basically. So this is a particular thing you can do it. And another thing, another question they might ask is like, what is a transform learning and deep learning? What is what is transfer learning in deep learning? All right. So they might ask this particular question, basic question. So imagine that you learn to bake a cake from a scratch. You follow a recipe, right? Gather the ingredients, bake it step by step. Now imagine you wanted to bake another cake that is similar with a different flavor. Instead of starting from the scratch, you use the knowledge and skills you gain from baking the first cake, adjust a few things to make it to form a cake, right? So in a deep learning, the transfer learning is like that when we take the pre-trained neural network, which has already learned a lot from a huge data set, okay, like a baking the cake and apply it to the new task or a data set like baking the second cake, instead of training the network from the scratch, we use we use what it already learned and we will fine tune it to the new task. Okay, this approach will save the time and resources because we are leveraging the knowledge and patterns that network already understand. So it's like using a baking and skills to bake the different cakes without starting from the beginning each time. So we are giving a knowledge base for the second time to have to add a second kind of a flavors. Okay, I hope you got the clarity like what is a transfer learning is all about now. Okay, so now we'll just get try to understand another question. It is like it's all about like VGG16 and explaining the architecture of VGG16. Okay, so we'll just try to understand what is a VGG16. They might ask like what is a VGG16? Can you explain its architecture? So you have to make it very simpler for this basically. First, you have to understand, explain them what is a VGG16. VGG16 is a type of a neural network model used for the task like image recognition and classification. It is a part of VGG and visual geometry group. They call it as visual geometry group. Okay, it's family of a models developed by the research of the Oxford University. Okay, so second thing, so what is a VGG16? VGG16 is a type of a neural network used for the task like image recognition and classification. It's part of a visual geometry group. It was developed by the Oxford University. These are the three things you have to understand. What type of a work, what is the type of a work, type of a model? First thing, type of a model, what kind of a task it can do, kind of a task, you have to talk about that. Okay, two things you have to talk about this VGG16 first. What is a VGG16? It is a type of a neural network model, right? So it performs a task of image recognition and classification task and developed by whom? Oxford University. Okay, if they ask, you can talk about it. Then second number two is like what's the architecture of VGG16? Architecture of VGG16 is input layer which accepts the images of the pixels type 224 pixels by 224 pixels. Okay, this is a fixed size that VGG16 can take. Okay, convolution layer. Second thing comes, one is the input layer IL, another one is convolution layer CL. In convolution layer, they applies the filter to the input images, okay, to the input images to extract the features, right? To extract the features like gestures, like edges, patterns. This is a particular convolution layer will do. Third thing is max pooling layer. This layer downsample the features obtained from the convolution layer, reducing the spatial dimension. Then fully connected layers, where these layers process the extracted features and make the prediction based upon them. Okay. Lastly comes the output layer. What output layer will do? It will process the final output such as class labels or image classifications, right? So understand there are basically five layers: input layer, output layer, okay. Then in between, convolution layer, max pooling layer, and fully connected layer. These are the three main thing understand. One is for any particular machine learning problem you take, there will be input, there will be an output. There is a two, right? So three things will come here: convolution layer, max pooling layer, and fully connected layer. These are the things, folks, you have to understand about the VGG16. Okay, is a deep learning architecture consisting of a 16 layers, hence its name is VGG16, folks. Okay, overall VGG16 is simplicity and effectiveness. Tasks like image recognition, like popular choice in deep learning community. Okay, so now next question, next problem, we will be going to understand about what is a ResNet. Okay, ResNet is nothing but residual network. Understood? So, like what it is a type. Okay, so another problem. What is a ResNet? Another question. ResNet, residual network. It is a residual network, folks. Okay. So in this particularly residual network, okay, it's type of a neural network architecture. Neural network architecture it is. It is a neural network architecture first, and it used like a task like image classification, object detection, and more. Image classification, object detection, and more. Okay, this is the two things. And here are the basic idea like ResNet, normal layer in neural network. So normally you can add more layers into a neural network. It becomes harder the network to learn because the problem called vanishing gradient. This means that information, okay, information from the earlier layers get lost as it flows from as many layers. So second is residual connection. It is like residual ResNet, something called as residue connection. This collection allows the information to bypass certain layers and directly flow to deeper layers. It's like having a shortcuts in maze. If a path is too long, it is winding, you can take it shortcut to end the faster, to reach the faster route. Okay, so this is something like that. By using residual connection, let's then train very deep networks, hundreds of layers more effectively. This architecture can be highly achieved and state of art of the performance where the task making it key advancement in the deep learning basically. Okay, so now there is a another question like what is an ImageNet, right? So another question, that is what is an ImageNet? Image Net. Okay. ImageNet is like a huge library of pictures on the internet. Like ImageNet is nothing but huge library of images over the internet. All right. But organized nearly for computer to learn from it. So it contains a billion of label images over a wide range of categories like animal, objects, and scenes. In the world of deep learning and computer vision, ImageNet is a famous because researchers used to train and test their models. Imagine you are teaching a computer recognizing different types of animal. You could use ImageNet collection of animal pictures to show the computer like what a lion, what a tiger, or what a dog looks like. Have a big collection like ImageNet helps the computer to better learn from the different things. It's like a studying from a huge textbook with a lots of pages and understanding topics like that. ImageNet is nothing but it is a collection library where you can get the predefined labels, predefined images to train your model and consider your system to predict that this is a image of a lion, this is image of dog, this is an apple, this is an orange, this is a mango. Basically, this is a particular ImageNet is all about. So ImageNet is like a treasure of all the images that computer can learn to see and understand world around us. Okay, so this is all about the ImageNet basically. Then another question comes into the picture is what is a darknet? Okay, another question they might ask like what is darknet? What is darknet? Okay, what is a darknet? So, darknet is a type of a neural network architecture used in deep learning. All right. So, it is known for the speed and efficiency, processing the images, videos, right? Especially in the task like object detection, OD, detection, and the recognition. Darknet architectures was developed by Joseph Randmon, and is properly used in application like surveillance system, autonomous vehicles, and robotics basically. Key features of darknet include a lightweight design, which allows it to run fast even on devices with limited computational power. It uses a series of convolution layer and other specialized techniques to visualize the data quickly and accurately, basically. So darknet includes lightweight design which eludes the fast even on the devices with limited computation power. In simpler terms, if I wanted to talk about the darknet is it is a supervised and efficient brain for the computers that help and see in real time, make it valuable for various application in AI and computer vision basically. So So last is nothing but what is an YOLO. Okay, I don't know whether you have heard about the YOLO. I will talk about it that first. And what is an YOLO and explain the architecture of YOLO. First, I will explain you what is an YOLO. YOLO is nothing but is a type of object detection algorithm used used in computer vision. Okay, what it is that object detection algorithm. YOLO is nothing but YOLO is object detection algorithm used in computer vision. It stands or you only look once, which means it can quickly and accurately detect the objects or videos in one pass. Second thing, architecture of YOLO. What will be the architecture of YOLO? Okay, the input will be the image. Okay, YOLO takes the input of the image or video frame, and second, it will divide the image into the grid of the cells. Okay, then third, it will make a prediction for each cell. YOLO predicts the bounding boxes in rectangles. Okay, it will consider of confidential scores, how likely the object is there, and class probabilities, what type of an object is about. Okay, then fourth, what it will do is non-max suppression. Like what it do, non-max suppression is nothing but it then uses a technique called non-max suppression to filter out overlap bounding boxes. Okay, keep on the most accurate ones basically. So then it will find the finally YOLO will use the final detection with bounding boxes and labels for each detected object. So let's suppose one particular object is found, so it will going to find it out that basically. All right. So this is a particular sense basically when the object is found. This is a particular thing, and one use case is like one common use case of YOLO is autonomous vehicle. For example, YOLO can help the self-driving can identify to track the objects like pedestrian, vehicles, traffic, signals and obstacle in real time. Let's suppose you have heard about the Tesla cars, Tesla motor cars, Tata cars. Basically, Ola is also into it now, right? So you can just see such kind of a projects can be done using this particular library. Basically, YOLO is a fast and efficient way for computers to see and recognize objects in images or videos. Basically, making making like valuable for application like autonomous driving and service and object tracking basically. So these are the certain question folks like I just curated and make you to understand in very simpler terms. If you want any GitHub resource, just comment down below in comment section. If you want this kind of a like if you want a GitHub URL for number of questions with the solutions, so you can go through that. Okay, so if you want, you can go through the content as well. You can go through with the video as well. So I'm making this video as very short and sweet and very keep crisp to understand basically. So this is all about the videos basically, folks. I hope that you enjoyed this particular video. Please, guys, plus just hit a like and subscribe to my channel. Okay, I'm making like another content I'm thinking to bring into my channel about the project series. Let me know about it. Let me know in comment down section below, folks. Let me complete this 30-day series. So I will be bringing that as it is. So whatever 3 months down the particular thing, what I'm planning is I will be going to bring into my channel. So only two things you have to do. You have to support me, and you have to just see to my like whenever the notification is coming to you, just subscribe to my channel. Just hit the notification button, folks. So otherwise you will not get notified whatever the content which I am putting into it. Okay, I hope this two things you have to do. You have to support me. I will be going to do it everything, every sort of stuffs which is there in the data science or technical related content. I'm going to think it, bring into my channel. Let me know which kind of a content do you like most, so that I can create a content based upon that. That's it about folks. That's it about this video, folks. I hope I will be taking wind up with this particular session. We will be going to meet in the next video.